Okay, so you just watched that video of him riding his bike, and he was talking about how fast am I going at one instantaneous moment. And I've mentioned this a couple times at the beginning of the course, but all of first semester calculus is really all about slope. And so this section that I'm about to get into, just to forewarn you, is rather lengthy. It's an important topic that is going to go for the rest of the entire semester and is really a foundation of calculus. So you might want to settle in or get comfortable and really pay attention on this video, even though I know it is long. So I feel bad it's an e-learning day, but it is what it is. And we kind of have to go in a sequential order, and there's not much wasted time. So it is a lesson that we just have to do as a video. So first of all, we're going to talk about how to find the slope of a line. And you guys know slope to be rate of change. So slope is rate of change. All right, you guys know that. And if you're going to find slope, you guys know the formula as y2 minus y1 over x2 minus x1, but really we just say it's the change in the y over change in x. We say it's the change in y over change in x. So like when you subtract the y's, that's the change in the y values. When you subtract the x's, that's the change in the x values. Some notation with that, if you've seen it in your science classes, change in y is known as delta y, and change in x is notated as delta x. And that delta x we've come across a couple times in this class already in problems that we've dealt with, and now we're going to get into what is it and why is it used in calculus. Okay, so if I have a graph over here, let's draw a little coordinate plane, and I pick 2 points, and I draw a line, and I label this first point x1, y1, and then the second point x2, y2, and I asked you all to find the slope of this line, I would imagine you would take m equals y2 minus y1 over x2 minus x1. And you find the slope in that line. Okay, so I have a little parabola here on the second one, and it says, how do you find the slope of a secant line? And it's pronounced secant, a secant line. So a secant line is a line that's going to intersect your graph in 2 places. So here, when I connect it, this line I just graphed is a secant line. It hits your graph twice. So if I want to find the slope of that line, well, we're going to use our slope formula. We have m equals 5 minus 2 over 3 minus 2. So you get 3 over 1, which is 3. So that's nothing new. You guys have been finding slope probably since 6th grade. The first problem of calculus is how do you find the slope of a tangent line? Because up till now, you've always needed 2 points to find slope. Well, if you have a tangent line, so like if I have a line here, I'm not going to draw it because I'm going to draw it here in a second. I'm talking about this line right here would be a tangent line at P. So if you only know 1 point from a line, how do you find the slope of it? Well, this is why the entire first chapter of limits existed, okay? So I want to name these points generically, all right? I have point P and point Q, and I want to name them generically, and you'll see what I mean. I don't want to put number values to them, all right? We have an x value of C right here. We have f of x, so this graph is f of x. And so I'm going to notate a few things here. And this is the way I'm going to notate this is important for you to understand. To go from the point P to the point Q, you have to go to the right some amount. Okay, you have to change your x to go from here to here some amount. So from C over to here to where the Q point is, that's delta x. Okay, so we have from our C value, from whatever this x value is, to get to the x value for the Q point, that's delta x. We have to go over some change in x. Okay, we can actually label point P here. The x value of point P is C. The y value of point P is whatever we get when we plug C into the f function. So the x value is C, and if we get the y value to find it, it would be f of C. Again, we're naming these generically because we want what we're about to do to apply to all circumstances, not just if I would plug a 2 and a 3 in there. Okay, so point P is C comma f of C. This would be the y value you get from plugging C in. Okay, let's look at Q. It gets a little more interesting at Q. So the x value for Q is whatever C is plus this delta x right here. So it'd be this x value right here. You take whatever C is plus you have to go delta x more. So point Q would be C plus delta x. That's your x value. Your y value would be whatever you get when you plug this into the function. So just like this one, it was c comma f of c. This is c plus delta x comma f of c plus delta x. So that's what I mean by name this generically. We're just going to apply this for any values, okay? So let's say I wanted to find the slope between p and q. All right, this secant line right here using this notation. So the slope would be, we're going to do y minus y, so f of c plus delta x minus f of c. And understand what this is. This is just taking one y value right here minus the other y value, which is right here. You're subtracting the y values. On bottom, you're going to subtract the x's. So you're going to take c plus delta x minus c. And then you notice in the denominator you have c minus c. Those cancel. So in the numerator you have f of c plus delta x minus f of c. Oops. Over, and the c's cancel, and you just get delta x. This probably looks familiar because I've already had you guys do a couple of problems in the beginning of this course that look like this. And the reason I did that was to practice the skills that we're about to do for the rest of these notes here. But this is known as the difference quotient. This is a difference quotient. This is really finding slope between any 2 points. This is called the difference quotient. So I'm still talking about finding slope between 2 points, but the whole lesson is about finding, your startup disk is almost full. Delete some files. I'm getting some error message. I don't know what that means. Hopefully it doesn't shut down on me. If it does, I'll just figure it out. Okay, so we're talking about the slope between 2 points. But what about finding the slope of 1 point, as what the whole lesson's about? Well, imagine this Q point gets closer and closer to point P. Okay, so imagine I put Q right here. And then imagine I put Q even closer. And then really close to P, but not on top of it. Okay, think about what's going to happen to this delta x right here. As I move Q closer to P, this change in x right here is going to get closer and closer to 0. This change in x is going to shrink, shrink, shrink as Q gets closer to P. Or in other words, delta x is going to approach 0. We want delta x to get really close to 0. Okay? So what we're going to say is, as Q gets closer to P, all right, because we're trying to find the slope right at P, we want this Q to get really close to P, delta x becomes smaller. Delta x becomes smaller. I don't know how to zoom out on that. Is that doing it? Oh yeah, there we go. Okay, so we get to a more accurate value for the slope of the tangent line. If we can get that Q point really close to P, where that delta x is getting really close to 0, we're going to get a great value for the slope of that tangent line. We're going to get really close to it. So if we want to find the slope, this is important right here, the slope of a tangent line, which is the whole foundation of first semester calculus, slope of the tangent at point C comma f of c. So in this case, this point P right here is c comma f of c. If we want to find the slope of the tangent line at that point, that equals the limit as delta x approaches 0. Remember, we want that delta x to get really small of that difference quotient we just talked about. We want delta x to get really close to 0. F of c plus delta x minus f of c over delta x. This is going to allow us to find the slope of a tangent line because we're going to evaluate this limit as delta x approaches 0. Okay? Obviously, we can't plug 0 in right now because we get 0 in the denominator, so we'll see what happens as we do some manipulation, if you will. So let's look at example 1. It says, find the slope of the tangent line to the graph of f of x equals 3 minus 2x at negative 1, 5. So there's a line here, right? 3 minus 2x is some line. And I want to find the slope of the line tangent to this function, or this graph, at negative 1, 5. So I want to find the exact slope at this point, okay? So we have to apply this right here. This is what we need to do. This is how we find it. This is how we find the slope of a tangent line. Those of you that are in physics, calculus-based, I think it's called ACP, you're not, at this point, you're not allowed to use your derivative shortcuts, okay? I know you know them. We'll get to them in this class, not today. But in this course, you also need to know where the derivative is coming from. You have to be able to apply this algebra because the AP exam will pose questions that force you to use the definition of limits with derivatives. So don't use your shortcuts yet. And that'll make you mad, but deal with it. So I want to find the slope of this. So I want to find the limit as delta x approaches 0. Now, this c right here, you see this c and the difference quotient up here? This c is just your target x value. That's your x value. So notice in this problem, they want the slope at negative 1, 5. Negative 1 is basically what you're going to plug in for c. C is an x coordinate. So when they tell you what the point is, take that x coordinate and plug it in where c is. So I'm going to do this. So I'm going to write f of, and where I see the c, I'm going to put negative 1 plus delta x minus f of c, which is negative 1, over delta x. So here's the setup of the problem. Notice it's that thing I have in the box right here, but where I see the c value, I plug in negative 1. And understand as you go through a problem what you're about to find, and when you get an answer, what you just found. Analyze those things. We're trying to find the slope of the tangent line. So basically we want that change in x to get really close to 0. So now we have some algebra to do, okay? We've practiced this a little bit, but I first want to figure out what this is. We have to figure out what f of negative 1 plus delta x is. So we need to take negative 1 plus delta x and plug it in for x right here. So this is going to be 3 minus 2 times, and then negative 1 plus delta x. I need to write limit. So the limit as delta x approaches 0. So f of negative 1 plus delta x, just plug in what's in the parentheses in for x. So 3 minus 2 times negative 1 plus delta x. So that's what f of negative 1 plus delta x is. Minus whatever f of negative 1 is. So we got to figure out what f of negative 1 is. So if I put negative 1 in here, I'm going to get 3 plus 2. So I get 5. Over delta x. So now we can clean this up. We have the limit as delta x approaches 0. Let's distribute the negative 2. So 3 plus 2 minus 2 delta x minus 5. I'm going to go through a little quickly the manipulation here. 3 plus 2 is 5 minus 5. So the 3 plus 2 and the minus 5 cancel. So we're going to have the limit as delta x approaches 0. The 5's cancel, so you have negative 2 delta x over delta x. We still can't plug 0 in. Remember, the whole idea, we're trying to manipulate this to get that delta x to go away. Well, now it does. So now we have the limit of negative 2 as delta x approaches 0. We could plug 0 in. Well, we don't need to plug it in anywhere. So the whole limit is whatever this constant is. So negative 2. So what we just found when we evaluated this thing, we were finding the slope as we were getting really close to this point right here. And what this is the slope of the tangent line to this line at negative 1, 5. And it makes sense. Think about this. What would the slope of this line be in general? Well, the slope's always negative 2. So no matter what point I plugged in over here, if I look at the slope of this line at that point, it's always going to be -2. That's not always going to be the case, but for this one it is. So the slope of this function at -1, 5 is -2, the slope of the tangent line. All right? Okay. So let's try this. I'll just go ahead and work it out. So it says, find the slope of the tangent line to g of x equals x squared minus 4 at 1, -3. So anytime I see slope of the tangent line, I have to think limits. All right, we have to use that difference quotient. So I'm going to write it again up here so I can use it. It's going to be the limit as delta x approaches 0 of f of c plus delta x minus f of c over delta x. Okay, this is our difference quotient. This is going to find us the slope of the tangent line at a specific point. Okay, so for this problem, our x value, our c value is 1. So wherever we see the c's, we're going to put 1 instead. So we have the limit as delta x approaches 0, f of 1 plus delta x minus f of 1, because c is 1, over delta x. Oh shoot, that's to be g. You guys probably realized that right when I wrote it, before I even did. Yeah, make sure, if they name a function a specific letter, make sure you use that in the problem. That's my fault. So this function is g. Alright, so now we have to figure out what g of 1 plus delta x is. So we need to input 1 plus delta x into x right here. So we have the limit as delta x approaches 0. So we are going to replace the x with 1 plus delta x. So you're going to have 1 plus delta x squared minus 4. So that's what g of 1 plus delta x is. This right here is what we just did right here. We inputted 1 plus delta x in for x, minus whatever g of 1 is. So g of 1, plug 1 in for x, 1 squared minus 4 is -3. So minus -3 is plus 3 over delta x. Now we still can't plug 0 in because we're still going to get 0 down here. So let's expand 1 plus delta x squared out. Okay, let's clean this up. So we have the limit as delta x approaches 0. When you square a binomial, you can't just square each term. Remember that. You can either put it twice and then FOIL it out, or I use a shortcut. I square the first term. I double the product of the term. So the product is delta x, so double it. So 2 delta x. And then square the last term. So square the first, double the product, square the second. So delta x squared. And then -4 plus 3 is -1. Okay. So we can clean this up more. The ones are going to cancel. So we have the limit as delta x approaches 0. The ones are going to cancel out. And if you notice in the numerator, both terms left have delta x in it, you can factor delta x out of the numerator. And so then you're going to have 2 plus delta x over delta x. These cancel. And so now you can plug 0 in for delta x because you're not going to have any issues that get caused. Remember, when you evaluate a limit, you can plug the 0 in or plug the value in and hope you get a value. Now you do. When you plug 0 in, 2 plus 0 is 2. And again, understand what you just found. The question was find the slope of the tangent line to x squared minus 4 at 1, -3. So if I was going to graph that, it's going to be some parabola. Y-intercept's -4. It's going to cross the x-axis at 2 and -2. You don't have to graph this, but I do want to give you a visual. So here's the parabola. And at 1, -3 right here, what we just found is what the slope of that tangent line is right here. We just found the slope of that tangent line. which, as we get into the course, is the instantaneous velocity. We're not there yet, but that's what we're finding. We're finding how fast was something going at that moment right there. That's really what you're finding, okay? All right. So I'm going to pause this to create a second file.